In example 2, we're going to write a rule for the nth term, and we also have some things to fill in. A sub 1 in this sequence is negative 2. The common ratio is what we multiply by every single time. It looks like we're multiplying by a negative value. A negative times a negative is positive, positive times a negative is negative, and so on. And it looks like we're multiplying here by negative 2. Negative 2 times negative 2 is 4, times negative 2 is negative 8, and so on. So in this one, it's kind of a special one where a sub 1 is negative 2, and the common ratio is also negative 2. You might be wondering why we call negative 2 the common ratio, but it's what we're actually multiplying by. And it has to do with another way of finding the value of the common ratio. You can take any term and divide it by the previous one, or set up a ratio, and that'll give you the value you're multiplying by every time. So 4 divided by negative 2 is negative 2, negative 8 divided by 4 is negative 2, and 16 divided by negative 8 is also negative 2. To write the rule, I'm going to write the formula here for a geometric sequence, and here it is. It's a sub 1 times r to the n minus 1 power. Now keep in mind we've got to follow order of operations. We're not going to know what n is, so we're not allowed to combine these two right here. Don't do that. Unless you are very good with exponents and you see a common base, and if that's you, go for it. But if it's not you, don't worry about it. We're just going to write the value of the first term here, that's negative 2. And again, in this case, r happens to also be negative 2 as well. Nothing else we can do with this one. It's good to go. A sub 1 in part B is 81, it's the value of the first term. The common ratio is what we're multiplying by every single time. Now you might be looking at this and saying, hey, I think I divide by 3. You'd be right, but we want to change our thinking a little bit to what we multiply by every time. And so if we divide by 3, that's the same as multiplying by the reciprocal, or 1/3. If you're having trouble with that, you can take any term, like let's say the third term, and divide it by the previous term, which is 27. If we simplify this by dividing by 9 on both the numerator and denominator, we wind up with 1/3 or 1/3. Turns out you can do that with any one of them. You can take the term and divide it by the previous one, and as long as that sequence is geometric, you'll always get the same number, and that number is the common ratio. The rule here then, following what we learned on the left-hand side, is a sub n is equal to a sub 1 times r to the n minus 1 power. If we look at example C, we find here that the value of the first term is 1. The common ratio is positive 2 in this case, multiplied by 2 each time. And the rule then will be a sub 1 is equal to 1 times 2 to the n minus 1 power. Or, if you prefer, we usually don't write 1 times a value. We usually just write that value, or 2 to the n minus 1. So either one's acceptable. This is kind of the cleaned up version, the one that you're going to see most often. But here it's also easy to see what the first term is. In example D, a sub 1 is 10. It's the first term. The common ratio, this one isn't jumping out at me right now. I know it's going to be negative because my sign is changing. But I think I'll use that old trick up here that we use. I guess it's not really a trick, but just how to find it, is we're going to set up a ratio. And we can divide by 2 in the numerator and denominator, and so we find that r is, or the common ratio is negative 1/5. The rule then will be a sub n is equal to 10 times negative 1/5 to the n minus 1 power.